Okay, students, so we're in algebraic reasoning, all right? This is a huge punchline of the whole geometry here is two-column proofs, all right? So, just a little talking right now before we actually start writing things down. In your math career, usually a teacher tells you something is true, and you just accept it as fact, you believe it, and then that's it. However, I know some of you, I know I did as a child, I used to wonder, how do they know this is true? How do they know that this works? Well, the answer is they proved it to be true. All right, so we have those postulates, those axioms, that stuff at the beginning of the year, the building blocks of geometry, the foundations. There's some things we just accept as fact to help us build upon and prove other things. Not to get too complicated, but you can't prove everything, because if you had to prove everything to be true, then you'd run into circular reasoning. So that's why we have postulates. Those are the starting points. We accept those as facts. Then we can build upon those and then prove really cool things to be true. So some things that we've learned before, like the vertical angle congruence theorem, we're going to prove that to be true. Triangles, I'm sure you guys are aware that the sum of the interior angles of a triangle add to 180 degrees. We're going to prove that to be true. So in this class, it's not that you just learn something, you accept it as fact and use it. We're actually going to verify it for ourselves. And this is actually a great life skill to have. It forces you to think abstractly. You need deep understanding on how to think critically. Just use a lot of problem-solving skills. So it's very dense stuff, very good things, and it's really going to help your brain grow. Remember, your brain is a muscle. You have to work it out and to be able to strengthen it and become smarter. But before we start geometric proofs, we're going to do something we're a little bit more familiar with, and that is the all-famous algebra. We're going to do algebraic reasoning proofs. This is just going to help us get used to a two-column format with something we're familiar with and go from there. And then eventually we'll start geometric proofs. All right, so we have a two-column proof because there's two columns. And the way we organize it, on the left-hand side, I have my statements. On the right-hand side, I have my reasons. All right. We're going to be given an equation. So it's this equation right here, actually. We have this equation. So let me just copy it down really fast. 2 parentheses x minus 3 minus 8x equals 27. All right. So we're going to prove that the one and only solution to this equation is x equals 21. So in this class, for two-column proofs, the first reason is always given to us. So we're going to state the equation, and it's given to us. Now we're going to step-by-step solve this. So we're going to practice organizing our work. All right? So in this right here, boop, boop, 10x minus 15. I distributed the 5 to inside the parentheses. Then I have a minus 8x equals 27. And we'll reason distributed the 5. All right. Now, in this next step, again, it's just solving an equation. On this left-hand side, we have a 10x and a minus 8x. So I'm just going to do 10x minus 8x. I'm going to get 2x minus 15 equals 27. I combined the x is. Cool beans. All right, now I need to get x by itself, so I'm going to plus 15 to both sides. So I'm going to get 2x equals 42. I have plus 15 to both sides. And then lastly, I have 2x equals 42. I gotta undo the 2 times x, so I'm gonna divide both sides by 2. I'm gonna get x equals 21 divided both sides by 2. Alright, so my reasoning was a little informal right there. I didn't use the best or most specific or what we're going to use in the future, but that's how you guys would say it. Alright, so now we're going to be a little bit more specific in our terminology. Alright, so we have some very general mathematic terms right here. We have the properties of equality. So we have the addition property of equality. So these are just some random numbers. If A equals B, then A plus C equals B plus C. So this is like when I plus 15 to both sides, all right? You're allowed to add something to both sides. You remember above I said plus 15 to both sides? That was just the addition property of equality. But in all truthfulness, we'll just probably say addition in the future. We won't write property of equality. Now this will blow your mind. If A equals B, then A minus C equals B minus C. And see how this is when you reduce something to both sides. You're subtracting from both sides. Multiplication property, if A equals B, then A times C equals B times C. So again, we do it to both sides to balance the equation. And then we have the division property. So above we said divided both sides by 2. In the future we'll just say division property of equality, or just division, shorten it a little bit. But C can't be zero. You're not allowed to divide by 0. It's illegal. One time Darby had a math teacher. He tried to divide by 0 in his class one time and he got fired on the spot. They said, you can't teach here anymore. It's illegal to divide by 0. Then we have the distributive property of equality. Above we just said distributed the 5. Now we're just going to say distributive, or distribute. But A times B plus A times C. Alright, then we got some other properties. These properties, some won't be too important right now. Some will be incredibly important in the future. They seem incredibly simple, but nonetheless. Alright, this first one is super complicated. Alright, make sure you're paying attention. If you're listening to any background noise, you have any TVs on, no music, you got to turn it off. You have to put your full attention onto this property right here. This property is the most complex property of all the properties that have ever existed. For any real number A equals A. Alright, now that might shock you, that for any real number A equals A. Alright, so that doesn't seem too important. Why are we learning this? We'll actually use it a tremendous amount in triangle proofs. Alright. So reflexive, also it's easy to understand, but it's hard to remember that it's called the reflexive property. Think reflexive, repeat. Symmetric property. If A equals B, then this will blow your mind as well. B equals A. Alright, so basically just saying it doesn't matter what order you write it in, it's still true. And this is more for equations like x equals 1 or 1 equals x. It's the same thing. Thousands of years ago, they thought that was important to understand and comprehend. And then furthermore, we have the transitive property, and I have a whole paragraph of transitive and substitution below and how we're going to differentiate between the two. If A equals B and B equals C, then A equals C. So actually, let's jump down to this awesome paragraph that I have. So this is a little bit more detailed because we have substitution property, we have the transitive property. They're almost the same exact thing, but there is slight variations. So the transitive property is when two numbers, variables, or quantities are equal to the same thing. Not necessarily each other right away as the given. Let's say we have two different equations. So we have x plus y equals g and x plus y equals z. So these are some just equations, but you notice something. They both have x plus y. G equals x plus y. Z equals x plus y. So the key for the transitive property is that one entire side of the equation has to match. So it's not just replacing one piece in these given equations. Because z and g are equal to the same expression, they must also equal each other. So the punchline of transitive is, since g and z equal the same thing, they must equal each other. Alright, this is the transitive property. And we're going to use the transitive property approximately 439,017 times throughout the year. Last year I counted. Next we have the substitution property. Alright, so we're going to compare and contrast the substitution property. Incredibly similar to transitive, but it is different. If A equals B, then B can replace A anywhere in an equation. Alright, so we got this follow-up paragraph on substitution. So let's say we have two given equations. So we're right here. A plus B equals C and A equals G. So A equals G. Since A is equal to G, we can replace A with G and make a new equation. So it's just boom, G goes there. So from this equation to this one, since A equaled G, I just substituted it in. And what I like to think is, think about basketball. You have 5 guys playing at the same time. You're allowed to substitute just one person out. Alright? When two things are equal, we can replace one with the other, and we know the equation will still be true. Alright, the substitution is the replacement of one piece. Alright, so substitution, transitive, incredibly similar, but there is a difference, and we'll elaborate in the future. Stay tuned for more.